Hi friends, I am Mohan from Sri Venkateswara College of Engineering, studying in Information Science and Engineering. So today I will explain about the topic named Dynamic Programming, which comes under the EDA, means Analysis and Design of Algorithms, having the more problems and algorithms. Let us discuss one by one about dynamic programming. Dynamic programming, a powerful optimization technique. Dynamic programming is a problem-solving technique that breaks down complex problems into smaller and overlapping subproblems. It stores the solutions to the subproblems to avoid redundant computations and leading to significant efficiency gains. So the definition says that a powerful optimization techniques which solving a technical problem by the breakdowns the complex problems into smaller overlapping subproblems. So the problems will be break down by complex into smaller problems. This is called a dynamic programming. Characteristics of dynamic programming: optimal substructure, overlapping subproblems, bottom-up approach, and memoization. So optimal substructure is a problem exhibits optimal substructure, and if optimal solutions to the whole problem can be constructed from the optimal solutions to its subproblems. Overlapping subproblems. Dynamic program problems involve subproblems and that are solved repeatedly by storing the results of the subproblems. We can avoid resolving them multiple times. Bottom approach. Bottom up approach. Dynamic programming typically solves problems in a bottom up manner and starting with the smallest subproblems and building up by the complete solution. Memoization. Memoization is a technique used in a dynamic programming to store the results of functional calls to avoid redundant computations. Optimal substructure. Examples: shortest path. So next we will discuss about the optimal substructures applications. Consider finding the shortest path from point A to point B in a graph. If the shortest path from A to B passes through point C, then the portion of the path from A to C must also be the shortest path between those 2 points. So the optimal substructure is widely used in algorithms for finding shortest path, minimum spinning trees and minimum spanning trees and dynamic programming problems. This is about optimal substructure. We discussed that examples and their applications. Overlapping subproblems. In that we will see three times types and recursive calls, memoization, optimization. Consider a recursive algorithm that calculates the nth Fibonacci number. Each recursive call involves calculating previous Fibonacci numbers leading to repeated computations. Memoization stores the results of functional calls in a table or cache, allowing us to retrieve the solution directly when needed. By avoiding redundant computations, memoization significantly improves the efficiency of the algorithm, reducing its time complexity. Memoization versus tabulation. Memoization and versus tabulation difference between it is a top-down approach and for tabulation it is a bottom-up approach. Stores result as needed, calculates the result in a specific order. May not compute all subproblems, computes all subproblems. More flexible, often more efficient. The main difference is that in the memoization, compute all subproblems, may not complete all subproblems in the memoization, and in a tabulation, it will complete the all subproblems. Common dynamic programming problems: Fibonacci sequence, knapsack problem, longest common sequence, edit distance. Calculating the nth Fibonacci number by sorting previously computed values. Knapsack problem: finding the most valuable subset of items that can fit into a knapsack with a limited weight capacity. Longest common subsequence. Determining the longest subsequence that is common to two given sequence. For edit distance, calculating the minimum number of operations that the insertion, deletion, substitutions required to transform one string into another. Fibonacci sequence, base cases, recursive relation, and memoization. The first two Fibonacci numbers are defined as 0 and 1. Recursive relation. Each subsequent Fibonacci number is the sum of previous two numbers. Memoization. Store previously computed Fibonacci numbers in a table to avoid redundant computations. Knapsack problem. Each item can either be fully included or excluded from the knapsack. Fractional knapsack. Items can be partially included in the knapsack, for example, taking off a gold bar. Longest common subsequence, sequence, subsequence, and common subsequence. A sequence in an ordered list of elements. A subsequence is a sequence that can be obtained by removing zero or more elements from a given sequence without changing the order of the remaining elements. A common subsequence of two sequences is a subsequence that appears in both subsequences. Conclusion and the key takeaways. Dynamic program is a powerful optimization technique that can be used to solve a wide range of problems. By breaking down problems efficiency, understanding the characteristics of a dynamic programming problems and the concept of optimal substructure and overlapping the subproblems is crucial for applying this technical frequency. And difference between memorization and tabulation. Top-down approach and bottom-down approach for tabulation. Store result as needed. Calculates result in a specific order. May not compute all subproblems. Computes all subproblems. More flexible and often more sufficient. So we know that the conclusion and the key takeaway says the dynamic programming is a powerful optimization technique that can be used to solve a wide range of problems by breaking down problems into smaller subproblems and storing the solutions. It significantly improves efficiency, understanding the characteristics of dynamic programming and problems that the concepts of optimal substructure and overlapping subproblem is crucial for applying this technical efficiency. Thank you guys.